Hello friends, welcome back to my channel. Today we are diving into one of the foundational tools for data science in Python, which is Numpy. We will explore what Numpy arrays are, the key attributes you should know, how to reshape Numpy arrays effectively, and type conversion. If you are working with data, this is super important. Before we jump into the coding side of things, let's quickly understand what makes Numpy so essential. Numpy is the core Python library for scientific computing built around a powerful multidimensional array object called ND-array. Why does Numpy matter for data science? The reason is many key libraries like Pandas, SciPy, scikit-learn, and Matplotlib are built on top of Numpy. Numpy gives you fast, memory-efficient tools for numerical operations, vectorized computations, and handling large datasets. Let's compare Numpy arrays with Python lists. With Python lists, you can store items of mixed types, but with Numpy arrays, all elements must share the same type and the array size is fixed. This restriction gives Numpy arrays two big advantages: speed and memory efficiency. That means you can perform operations like element-wise maths or matrix computations much faster than you could do with plain lists. Because of these advantages, most data science libraries rely on Numpy arrays as the backbone for numerical computation. So Numpy arrays gives us speed and efficiency, but how do we actually create them? Let's check it out. Numpy arrays can be created in several ways, from Python sequencers, using array creation functions, using ranges, using random generation, and from existing data. Let's try some examples. First of all, we need to import the Numpy module. Let's try some examples on how to convert a list to a Numpy array, then how to create an array of zeros, how to create array of ones, how to create an array filled with a specified value. In this example, we convert a list or tuple into a Numpy array. For that, we use numpy.array method and we pass the list as parameter. So the result we got is a Numpy array which has the specified values. Next, let's try to create an array of zeros. For that, we use the numpy.zeros method. 2, 3 is the resultant array's shape. So there will be 2 rows and 3 columns, and the values will be zeros. Let's see how to create an array of ones. For that, we use the numpy.ones method and pass the dimension of the resultant array. So all the values will be 1. We have created array of zeros, array of ones. Let's try how to create an array with a specified value. For that, numpy.full method is used. Pass the dimension of the resultant array. Here it is 2 by 3, and this is the specified value. Here is the result. Let's try to create an identity like matrix. For that, we use numpy.height method, and 3 is the dimension of the resultant array. Here an identity like matrix will be created with 3 rows and 3 columns. If you want a different number of columns, then you can pass it like this. So let's try the result. Here is the result. So what is an identity like matrix? It's an array with ones on the diagonal. We can see only ones on the diagonal and zeros elsewhere. In the next two examples, let's try how to create evenly spaced values. For that, one method you can use a range method. In this example, the resultant array will contain numbers between 0 and 10 and they will be evenly spaced with a difference of 2. Let's try another method. This example creates 5 evenly spaced values between 0 and 1. In the next two examples, let's try to create random values. So this example generates random values between 0 and 1 and the resultant array will have the shape 2 by 3. So these are the floating numbers. Let's try to create random integers. For that we use the randint method, and this example creates random integers between 0 and 10 and the size of the resultant matrix will be 3 by 3. Similar to numpy.array, we can create numpy array from other data using numpy.asArray method. And this method will avoid copying data whenever possible. Great, we have created some arrays. However, to work with data properly, we need to understand the structure of these arrays. That's where attributes come in. NumPy arrays provide useful attributes such as shape, endim, size, and dtype to describe the structure. Let's try to find the dimension of an array. So in this line of code, we have created a NumPy array from this data. And to find the dimension of the NumPy array, we use dot shape attribute. So here is the dimension. This array has 2 rows and 3 columns. Next, let's try to find out which attribute should be used to find out the number of dimensions of a NumPy array. So this is the NumPy array and we should use ndim. So this NumPy array has 2 dimensions. Next, let's try to find out the total number of elements in a NumPy array. For that, we use the size attribute. So in this array, we have 6 elements. In the next example, we will find out the data type of the elements. For that, we use the dtype attribute and the result in 64, which means this NumPy array has integer type elements. So those are some of the attributes of NumPy array. If we want to convert a NumPy array into a different data type without modifying the original array, we can do that by using the method asType. Let's try an example for that. In this line of code, we have created a NumPy array. These elements are of integer type and we need to convert this NumPy array to a float type. So we use the asType method. Let's run the code. So this is the converted data. To check the data type, we use the dtype attribute and the data type of the current NumPy array is float. Once you know your array's shape and dimensions, the next powerful skill is reshaping. Reshaping means changing how the data is organized without altering the values. Reshaping of NumPy arrays can be done using methods like reshape, ravel, and flatten. Reshape method is used to change the NumPy array's dimensions without altering the data. Ravel method returns a view of the array whenever possible and changes may affect the original array. On the other hand, flatten always returns a new copy. The original array stays unchanged. Let's try the first method, reshape. So initially it's a 1 by 1 array. We need to change it to 2 by 3 shape. So we use the reshape method. It's a 2 by 3 array and the elements are not changed. Let's try the ravel method. Ravel method flattens a multidimensional array into a one-dimensional array. Here is the input array. We use the ravel method. Let's check the output. That's it. Next, let's try the flatten method. Flatten method 2 is used to convert multidimensional array to one dimension. Here is the input. Use the flatten method. Let's see the output. That's it. The difference between ravel and flatten is flatten always returns a new copy and ravel returns a view whenever possible. Another difference is for ravel, the changes may affect the original array and for flatten, the original array stays unchanged. Mastering NumPy is an essential step in your data science journey as it provides the foundation for fast, efficient numerical computations in Python. So that's it for this episode. If you enjoyed this information, don't forget to like and subscribe. Also, stay tuned for the next episode of this data science series.